Okay, so they tell us we have 25 grams of silver nitrate. And
Actually, 25 grams of sodium chloride.
oh, sodium chloride. Okay. Sodium chloride. Excess.
The excess was of silver nitrate.
Okay. So, first things first is we're going to have to write a balanced equation. So we're going to have sodium chloride on this side. And we know it's aqueous by using our solubility rules. We can see over here that group 1 are always soluble. So group 1's over here, and the sodium is right over here. So sodium is always soluble, which means that this is aqueous, plus our silver nitrate. And this one's aqueous as well, because if we look over here, nitrate is always soluble as well. So once we do that, we're going to have to do a double replacement to double check to find the products. So it looks like we're going to be forming silver chloride plus sodium nitrate. Now we're just going to double check if these ions are properly balanced. So the silver, this is just memorization, but silver has a charge of +1. Chlorine has a charge of -1. Sodium has a charge of +1, and the nitrate ion, polyatomic ion, has a charge of -1. So everything adds up together to form a total charge of 0. So everything's neutral, which is good. Now let's check whether they're solids or liquids or aqueous. So if we look over here at AgCl, look at chlorine. This tells us that chlorine is soluble, except when it is paired with silver, mercury, or lead. Now we're pairing chlorine with silver, which means that this is part of the exception. It's a solid, because it's insoluble. Now this one over here, sodium is always soluble in solar nitrates, so this one's dissolves into aqueous. Right. So 25.0 grams of this sodium chloride. The question is, how many grams of silver chloride can we make from this? So what you do is you start with your given. You have your 25.0 grams in ACl. Now you're going to have to do this step because you want your grams to turn into moles. So you can do a mole to mole conversion. But to do that, you're going to need the molar mass. So 1 mole of sodium chloride is going to be, so sodium is 22.99, chlorine is 35.45, so add those together and we get 58.44 grams. Okay. So the purpose of using the molar mass is to go from grams to moles. And this also works the other way around. It just depends on your dimensional analysis, which way you're going to set things up. So from here on out, since we have theoretically canceled out the grams, we're left with moles of sodium chloride.
Okay.
So the next thing to do over here is we want to go from sodium chloride into silver chloride. So this is like the actual step you want to achieve. If you look over here, this cancels out the sodium chloride because it's one on top, one on bottom, cancels each other out. And we're left with moles of silver chloride. And we got this 1-to-1 ratio from the equation. There's 1 mole of sodium chloride to 1 mole of silver chloride. So looking at this, we can see that we've effectively turned our grams of sodium chloride into moles of sodium chloride. And then for moles of sodium chloride into moles of silver chloride. Now we want grams of silver chloride. So whenever you want to go from gram to moles or moles to grams, you're going to have to use the molar mass. So if we set this up, we're going to start with moles. So moles should be on the bottom because we want to cancel out this mole with that mole. So moles of silver chloride. 1 mole of silver chloride has, let's see, silver is 107.7.
0.7. 107.87.
0.87. And then chlorine is again 35.45. Add them together, and you get 143.32 grams. So after you do this, you do the math, 25 divided by 58.44, multiplied by 143.32. And we get 61.31 grams silver chloride. Now I'm going to go an extra step here and do the sig figs. Sig figs, we were given 3 in this one.
3, yeah.
So our answer should be 61.3 grams of silver chloride. But that's how you do basic stoichiometric conversion and finding out which one is a precipitate.
Gotcha.
Yeah.